All right, boy, this video is kind of a mess. The situation here is I assigned a task in my entry-level JavaScript course where we were just playing around with filter and map and functional programming, and it's one of those situations where the task just became, well, really, really unwieldy. So rather than kind of assigning it, I've decided to make kind of just this overview walkthrough video and kind of just throw in a whole bunch of, intermediate to advanced concepts in here so that if you're watching this video, you can at least hear the terminology and maybe, just maybe, you'll get something out of this. Of course, feel free to ask follow-up questions and comments and try to respond to those. So just to kind of set the stage here a little bit, this is part of a project that we've set up in a template repo, and we're using Vite as our bundler along with vtest. So let's just briefly touch upon what that means. So Vite, if you're not familiar, is sort of the successor to things like Webpack, where it just takes our JavaScript project and does a lot of super awesome stuff really, really quickly, including a local host server, hot module, instantaneous reloading, where if we change the code, among some other things, and it takes care of our imports and exports, bundling those up and optimizing those. So Vite is awesome to check out if you haven't already. Going along with that is something called vtest. So before we talk about vtest, let's talk a little bit about testing, because if you're watching this video, maybe you've heard the term testing, maybe you've never seen any testing. I can say that in our class, we have not actually done any testing, and it really wasn't the intent to cover it, but what the heck, I'm making this video, we'll just see what happens. So testing. Ordinarily, we'll just when you're learning how to write functions and stuff, how do you test to make sure that the function is working correctly? Well, usually you have to create some variables and call the function and pass it in and maybe console log some stuff and then run the code and, do it 2 or 3 times and keep checking it. In real life, that's just not going to cut it. Like in real projects, it's always being updated and things are changing and multiple people are working on stuff. There's got to be a better way to do it than just doing manual testing, right? We can't just constantly be doing manual testing. And that's the whole motivation behind testing frameworks. So every language out there has various testing frameworks. And in JavaScript, one of the big ones from Meta was Jest, and that's pretty prevalently used. But this is kind of the successor to it. It's just a better, faster version of Jest. So we've sort of set the stage here specifically for the use of vtest. We've established what is testing just in general. Forget about JavaScript, just in programming. And it's basically what I described. You can, how do you test your code is working? You can just randomly, or just keep running it over and over again with random arguments and console log this and that and the other thing. Or you can have a framework in place that, similar to how Vite works, it's going to be watching your code and constantly running your tests, and it's going to let you know when you break something, when you screw up. Okay, so that sets the stage for a couple of things we're using in here. So if we switch back over into the code, we have a script here just to run vtest, and we're using Vite like we talked about, and here's vtest that we installed as part of our development dependencies. So what does that actually look like? Well, it looks like this. I just run npm t. So npm t is a short way of typing npm run test. It only works with some things like T for test. Anyway, npm t, and as soon as I do that, in 6 milliseconds, it checked this particular test file. It ran the function that I'm going to show that I implemented, and it just shows me that the test is passing. So this is still running, and if I were to make any changes to either the test or the actual function, it would rerun constantly. So without going any further, you can start to see how this can be incredibly valuable in larger applications where you can't really be too afraid to change things and make updates and then spend the whole rest of the day manually running code. You got to have testing frameworks in place. So there you go. That's sort of the motivation behind writing a test. So now let's look at how that's actually implemented. Now, before I show that, I want to point something out here. I'm going to deliberately show the test before the actual function code. And that is a nod to another term that you may have heard somewhere possibly, and that's test-driven development, or TDD. Now, just like anything, sometimes people take things too far and everything's got to be TDD all the time, but it is definitely helpful to be familiar with the term. So what does that term mean? Test-driven development. Well, again, this is not a JavaScript thing. This is just programming in general. It's a strategy to where, especially when we're writing like individual functions that we're going to be using in larger parts, other parts of the project as part of a larger project, you write the test that describes what it is that you want to do, and it sets up some test conditions. And you run that test and you watch it fail. Why would it fail? It would fail because you haven't written the function yet, right? You've just set up a test and you want to make sure that the test fails. Because if you just wrote a test without writing the function, and for some weird reason the test passed, it's not a very good test, right? So that's test-driven development. You write the test first. You watch it fail. I've kind of skipped past that part, and because I already wrote the function and it's passing. So you write the test first, you watch it fail, and then you write the function code to make that test pass. And that allows developers to really focus in and hone in on one particular feature and making sure that that one feature works. Then if you need other features, you write more tests, you watch them fail, and you write the function code. So far we've talked about why we do testing, and we've mentioned something called v-test, and and then we talked about test-driven development. So now let's close this out and actually show off the test. And I think even if you've never seen testing before, as long as you're familiar with JavaScript syntax, it should be somewhat easy to read. Let's take a look. Okay, so here's the test. So we installed v-test, and we're using the import statements as part of ESM or ECMAScript modules to import in specific parts of this v-test that we installed. And then this here is our actual function in a file that I'll be showing off in a little bit, but it's right here. It's in a file called library or lib, because that's kind of a common thing. Developers might have like utils or a function library or something, and that's what we're trying to do here a little bit. So we have this particular function in that file that we're importing in. So that's just the imports. Now here's the actual test part. And you just use the word test. You can also use like it, and there's a couple styles of how to write this. I'm just going with test. So I just wrote test, and I just wrote the name of the function that I'm testing. That's it. So that's how it starts. And then, as with a lot of things in JavaScript, you pass in a callback function, right? So when this test runs, when it calls this test function, the test function calls back to this anonymous callback function. So again, as long as you're familiar with the basics of JavaScript, this won't be, too unnerving. Now, whenever we're writing a test, and this is something that applies to any sort of programming, this is not specific to JavaScript or v-test, there's the 3 A's of testing. The first one is arrange. And arrange is where you arrange your inputs and your outputs. You arrange your tests. It's sort of, if you have any sort of a science background, even in high school or something, you would make like a hypothesis. You would hypothesize that when we do this thing here, this is going to be the result or the effect. It's very similar to what the arrange is. So even without knowing too much about what this is about, just looking at the arrangement gives you some idea of where we're going. So we're going to have 2 arrays, and these arrays, they're corresponding items. So term 1 corresponds with corresponding 1, term 2 with corresponding 2, etc. And we're going to have a filter term. The idea is we are going to use the filter term to essentially filter out term 2 from the terms 1 array, while at the same time we want to get rid of the corresponding string there. So this sets up our inputs. What I need to do actually is, rather than doing it like this, I want to set up our outputs. Here's what the output is actually supposed to look like. I'm going to say const output. There we go. Get rid of this. And here, this I think makes it a little bit more clear, and we're truly arranging everything up front. Okay, so now this shows the whole arrangement. Essentially, in sum, given this input, this is the output we expect. So if we're writing a pure function, it should be able to take in the same input and always give the same output. It's not going to have any side effects or reach outside of its scope or be dependent on anything. So pure functions are ones that are easier to test because they are very reliable in terms of given input X, you always get input Y. Okay, so there's arrange. It's the first step of writing any test. Then you act. That's just running your function. So looking at this, we haven't looked at the function yet, of course, but we're going to pass in a single object that includes these three keys inside of that object. Now, let me just clarify, because you may or may not be familiar with object shorthand. So I'm going to jump out of here for just a minute, just scroll down here. So given, if we just say like const name equals whatever, this is object shorthand. Let's say I was creating a person object literal. I could do this. Okay, so what are we saying here? We're saying, hey, I want to create an object person with a key of name, and the value associated with the name happens to be this variable name up here. In other words, the key and the value are the same name. And, oops, need to not have a semicolon there. And there you go. Our linter is set up in a way where it's going to give us some guidelines, and it says that we expect you to use property shorthand. So if I hit Command S, it shortens it up. So in other words, if you have a situation like this, you can shorten it up like this. This means the key and the value are both called name. Okay, so we'll get that out of here. I just want to cover that so that you understand that here, this is the long way of what we're actually passing in. Right, so this is the, oops, I don't know what happened there. Filtered. Okay. So this is like the property longhand way. We're saying the key is terms one, the value and they just happen to have the same names, right? So if I hit Command S, because of the way that we've got our tooling set up, it'll shorten that up right away for us. So just understand that this is property shorthand or object shorthand, and it just allows you to not type as much. That's it. Okay, so moving on, we've done the act. So we've set up our arrange, our inputs, and our expected output. In fact, I'm going to use a different name here. On VS Code, I'm going to hit F2 and call this expected, because it's not the actual output, it's the expected output. And on here, yeah, result or output, same type of thing, right? So this is the expected, and then this is the actual result from running the function, arrange and act. And finally, we have our assert. And those are the 3 A's of testing. That's something that applies no matter what programming language you're working in. All right, so that's how we write a test. So if we were following test-driven development, that's what it would mean. You don't write the actual function code. I mean, you set up the function so it doesn't crash when you try to import it. You just write like an empty function, or you just say console log implement this or something like that. You have some sort of a function. And then you write your test that describes what it is you're trying to do. So that way we've picked up regarding testing. Now we know the motivation behind testing, or you have some exposure. I don't expect you to actually know all this, but we have some exposure to testing. We have been exposed to the term test-driven development, or TDD, and we understand the 3 A's of testing: arrange, act, and assert. So those are all things that have nothing to do directly with JavaScript or VTest. We just happen to be using JavaScript, and we're using VTest as our testing framework. So that gives us an idea of the test and all those terms. And finally, let's look at the actual implementation here. All right, so what is all this? So while I was going a little bit over the top here, we're not actually doing TypeScript. So TypeScript, just to give an idea of what TypeScript is, in JavaScript, JavaScript is very loose You can pass in whatever data you want to any function you want, and you just have to run the code, and if it crashes, it crashes. There's nothing like up front that tells you, hey, this is supposed to be a string, but you're passing in a number. So that's what TypeScript is. TypeScript wraps around JavaScript and helps us during the developer experience to kind of get a heads up that we're doing something wrong. So we're not doing TypeScript, so the next best thing that kind of gives us that benefit is right here. We can write these JS docs. And let me tell you that TypeScript is going to be a little bit simpler to write than all this messy stuff. I don't want to spend too much time on this part of it, but if you're wondering what the heck all this weird stuff is, so we're specifying a couple of types, type definitions, and we're saying this is going to be an object, and we're giving this object a name, remove corresponding items by term args. And inside of that object, it's going to have these three properties. It's going to have a string, array string, an array string, and a regular string. If we go back to our test, I mean, that makes sense, right? Whenever we call this, this function, this right here, it's going to be an object with terms. That should be an array of strings. Terms2 is an array of strings, and filter term is a string. That's what we're trying to describe here. We're trying to lock down those types a little bit by using these JS docs type definitions. And then down here, we have another type definition, and as you might surmise, this is going to describe our returned results, right? If we look at the expected here, it's an object with a property called terms1 and a property called terms2, and these are string arrays. So that's what all this gibberish up here is. It's trying to lock down the types a little bit using JS docs type definitions. Again, doing this with TypeScript would be better, but that would involve a lot more setup and a lot of other stuff. Okay, so moving on. Now we have some JS docs that just give us some documentation about this function, and it says the param is going to be, we can just give this any name we want, the arguments that we're going to pass in, and it's going to look like this type that we just told you about up here, right? That's what this is saying. We're going to give you one param, and it's going to be of this type of format that we just described up here, and it's going to return terms, which is going to be an object with these two properties. So that is all of this gibberish up here, the JS docs. It's sort of a precursor to TypeScript or something to that effect. But anyway, if someone doesn't have TypeScript set up, even though this is a little bit tedious, it may be better than nothing, right? It's better than nothing. At least when people go to use this function, they'll get some feedback in their editor when they don't conform to what this stuff is. All right, so JS docs. We'll just collapse these now to get them out of the way. And here is the actual function. I'm going to clear out these comments. You might want to pause the video, but you should have an idea of where we're going with this. But I'm going to delete these comments. And here we go. So remove corresponding items by term. Now that we've already seen the test for this, you might have, a rough idea of what's going to happen here. As expected, in fact, I'll keep the test open on this side. As expected, we're going to pass in a single object, as we already showed here and we already talked about in the type definitions, and it's going to have three properties. Okay, so we know that terms1 is an array. So here we have terms1 dot reduce. So what is reduce? Again, this is just a high-level explanation, but reduce is another one of these object methods we can call on, and specifically on an array, I should say, and we call it on any array, and reduce takes in a callback, and it's extremely powerful. It allows us to take that array, iterate over it, and basically create just about anything else that we want out of that array, out of that iteration, without affecting the original arrays. So it is the most powerful out of all of the array methods, and a little bit complex. Let's see if we can at least get the basics here. So let me collapse all this stuff in here, and let's take a look just at the reduce method. We can see here it's going to take in two things. It's taking in a callback function, and it's taking in a second argument down here. So what is this? I'll actually put a comment in here. There we go. Initialize the results arrays. So when you run a reduce, the first thing you do is your callback, which is kind of all the logic that you want. And then down here, the second argument is where you establish what it is that you want to get back out of it. So if we go back to the return results that we're looking for, we want an object with terms 1 and terms 2, and they're going to have values that are arrays. So hopefully it makes sense that we're going to start with some empty arrays. We're going to run our reduce and kind of start building out these arrays until we're all done. That's the high-level strategy. So with that out of the way, let's take a look at the callback function. So we have something in here that we can call whatever we want. I called it accumulated results. So this is supposed to let you know that we're going to start here. We're going to be iterating over the array and continually to build or accumulate those results. And then we have whatever term we're working with as we iterate over the array and the current index. So we take a step back before we open up the code. If we see terms 1 here, that means this reduce is going to run 3 times. And that means it's going to start right here, and it's going to do the logic, which we haven't seen yet, but it's going to start with those accumulated results, and then it's going to look at the first term, which is term 1, and it's going to keep track of the index, which is, of course, going to be 0. So that's the little bit of a breakdown of what it means when we say terms1.reduce. So now let's start opening up some of these pieces here. So the first thing that we're doing here is it's another kind of a, I don't know if it's clean code or a linting principle or something like that. It's generally a good practice where whenever you receive a certain parameter, any parameters, you want to try to avoid mutating those directly. So the first thing we're doing here is using a spread operator. So we're going to take those accumulated results and we're going to make sure that those don't get unnecessarily changed. Instead, we're going to spread everything out and put them together into a new object. So this is kind of just a placeholder that says, hey, you give me the accumulated results and I'll just put those to the side and I'll kind of make a separate, totally separate copy of it over here, just so that we can work with that. Okay, so we have, every time we run this, we're taking our accumulated results and then we're making a completely separate copy to avoid mutations. This is a very common pattern to do that. You spread out the object and wrap it in some braces, and that creates an entirely new object. That helps you avoid mutate. Doesn't guarantee, but it does. It works in this case. Okay. Now, as we iterate, what are we trying to do? If the current term does not include the filter term, add it to the results array, right? So in other words, we come in here, here's term 1, and term 1 doesn't include term 2, so we'll keep it. We get to term 2, oh, this is the same as term 2, or it includes term 2, then we're not going to keep that one. So that's all this statement is saying here. As we can see in the expected results, we're expecting to keep term 1 and term 3. So this comment here kind of corresponds to that. Okay. Next, so that's what the if statement is here. So if that's the case, what is it that we want to do? Well, remember these accumulated results, the ones that we made a separate copy of? They have terms 1 and terms 2 in here. So I want to take the terms 1 property, and I want to give it a brand new array. Again, avoiding any mutations instead of doing like push and stuff like that. We want to take whatever the results are. Again, we're using a spread operator, which works with arrays too. Take whatever results are there in terms 1. I mean, the first time through, it's empty, so it's just empty. Whatever's in there, though, whatever results we already have, spread them out and give me all of those items. And then mix in the current term that we're looking at. And this is how we continually build up the results here, right? So we're saying keep iterating over this entire array, and then, if the term is not in there, so we get to term 1, this is going to spread out that empty array, and then it's going to end up with the string term 1 the next time, and it'll keep doing that over and over again. So this is how we're building up our terms 1 results. It's essentially a filter, right? It's essentially running a filter, just in a more particular way. And while we're doing that, add the corresponding term for terms 2 to this results array. So same type of thing here. Take whatever results we already have for terms 2, and then go to the original terms 2 that we passed in. Whatever index it is, we want to keep that element. So just to kind of step through this using this over here, we start with terms 1, and we run the reduce on it. The first term is term 1, and the first index is 0. So we look at our little condition here. We say if term includes the filter term. In other words, if term 1 includes term 2. As long as it doesn't include that, we want to keep term 1. So go to our results, spread them all out, and put term 1 in there. And now we know we're at index 0, so for terms 2, spread this out, and then go to terms 2 bracket 0. So that's corresponding 1, and that'll end up in there. So yeah, this one is way over the top. Like I said, this was a mistake. Like, well, let me do something with it. So I made this kind of crazy video. So I don't know if it's helpful at all. Hopefully you got something out of this. When it's all said and done, we just keep repeating that process, and we return the results, and it keeps going over and over again. So this is how a reduce works. It iterates over an array, and it allows you to transform or create a new result. See, with map is pretty cool with an array. However, you can only get back an array. What if I don't want an array? I want to iterate over the array, but I want to create something totally different. And in this case, I want to create an object with these properties, and each of those has its own array. This is a use case for reduce. So that's it. Just to maybe kind of wrap this up, we talked about testing, why we do testing. We talked about test-driven development, where we write the test and then write the function. And we talked about the 3 A's of testing: arrange, act, and assert. Sort of like setting up a science experiment. Then we talked about the JS docs notation, which helps us define some types. Again, TypeScript is really the way to do this, but I happened to just want to show this off while I was doing all this craziness. So we wrote some JS docs that basically describes the inputs and the outputs of the function and assigns some type information to it. Then we finally showed the actual function, and we matched it up with the test. You know, we saw what the test does, and we can see why the test passes. We received that first array, and it runs the reduce on it. And down here, we're initializing the results. Actually, I shouldn't say results arrays, should I? I mean, sort of, but I'll just say initialize the results. So this comes in initially, like it starts off like this, and then we go through this process. If we end up wanting to keep the term because it does not match or include the filtering term, then we will build up this terms 1 array. It started off as empty, but bit by bit, we're going to add the term in it based upon this if condition. And while we're doing that, since we know the index that we're on, we'll do the same thing with terms 2. And so the result of that is, again, like we saw in the test, here's our terms 1, here's our terms 2, here's our filter term. This keeps running, and it starts off with these empty arrays down here, and it ends up looking like that. And that's all I have to say about that. Crazy stuff.